For question 15.21, we're given a 0.05 molar solution of pyruvic acid and it has a pH of 1.85. And then we're asked to find what is the Ka for pyruvic acid. And they tell us it's a weak monoprotic acid. So I'm just going to write out our generic equilibrium for this. We have our generic weak acid, HA, which is pyruvic acid in this case. It reacts with water to form the conjugate base A- and hydronium, where our Ka would be products over reactants, so the concentration of the conjugate base times the concentration of hydronium all over the concentration of our weak acid. Right? We're going to ignore water because water is a liquid. It does not show up in our equilibrium expression. So we are given the concentration of the pyruvic acid and we're given a pH value and asked to find Ka. So right now we have a few too many unknowns. We actually do know the concentration of hydronium because remember, pH is the negative log of hydronium. So we can find the hydronium ion concentration because that equals 10 to the negative pH. So I can find the hydronium concentration by taking 10 to the negative 1.85. That's going to give me a concentration of hydronium of 0.01412 molar. So now I know my hydronium concentration. I also know the concentration of the conjugate base because looking at the balanced equation, for every one molecule of hydronium formed, I'm going to form an equal amount of the conjugate base. So I know both of those concentrations. And this one's a little bit different than the one we did in class because the concentration of the hydronium is relatively large compared to the concentration of pyruvic acid. So we have to check our percent ionization to see if we can safely assume there's no change in the concentration of our acid. So our percent ionization is what is the concentration of hydronium all over the concentration of HA times 100. If that's greater than 5%, then we cannot make that assumption that the change in concentration is negligible. So we have 0.01412 all over 0.05 times 100 to see that the percent ionization is 28%. So I cannot make that assumption that the change in concentration is small enough to be ignored. So I do need to take into account that change in concentration. So if we were to set up an ice table where I have HA and I have A- and I have my hydronium, I have my initial, my change, my equilibrium concentrations. So initially I would have 0.05 here, 0 and 0. During the course of the reaction, right, plus X and plus X, I found out what X was. And in this case, normally we ignore the change from our initial concentration of our acid because it's small enough. In this case, we do have to take that into account. So we found out X. We know X already, right? X is 0.01412. So I can go through and I can add that and I can subtract that. So my my equilibrium concentration of my weak acid is 0.0358. And I've got 0.01412 for here and here. So now I can calculate what is the Ka of pyruvic acid. Ka equals the concentration of the conjugate base, 0.01412, times the concentration of the hydronium, 0.01412, all over the concentration of my weak acid, which after taking into how much went into solution is 0.0358. So multiply and then divide, I get a Ka of approximately 5.6 times 10 to the minus 3. 5.6 e to to the -3 for the Ka of pyruvic acid. And again, this one was a little bit more involved than the one we did in class, because the one calculation we did in class, the change in concentration was so small, right? It was less than 1%. So we were safe in ignoring this change in concentration of our initial acid. In this case, the percent ionization is much higher, and because it's so much higher, we have to take that into consideration when calculating our Ka values.